Motion. What is it and how can we make sense of it? The words that you are about to hear are not new words. In fact, a lot of us use these words every day and they still have the same meaning even in a scientific context. Those words are speed, velocity, and acceleration. Think about a car moving at 55 miles per hour. The speed at which the car is moving is 55 miles per hour, right? Now, if you say that this car is moving at a speed of 55 miles per hour in the northwest direction, you've just defined its velocity. Velocity defines the speed in a given direction. The third word is acceleration, and this is defined by the change in speed. A common example will be when you are moving in this car and you have to decelerate to come to a stop. That is a change in speed. Now, you might usually think of the word acceleration as being an increase in speed, but in science, acceleration is merely the measure in the change of speed, whether that's an increase or a decrease. Forces directly impact the speed, velocity, and acceleration of bodies. Forces will change the motion of any object and are typically from the interaction of more than one object. If that force changes with time, we call that momentum. The momentum of a body is measured by how the forces that are driving it to move are changing with time. A relevant example for us would be the force by the sun onto the earth that keeps the earth orbiting around the sun. That force is just the sun's gravity, but it's applied to the earth, which actually gives it some form of momentum. In this case, it's angular momentum. This angular momentum is what keeps the earth bound to the sun, orbiting it. Humans experience and even generate their own angular momentum too. Did you know that? For instance, when you're driving in a car and turning, you're generating angular momentum. The force that you feel that's pulling you away from the direction that you're turning, that's the force that's responsible for the angular momentum. Believe it or not, gravity is a lot like a force field. It manifests itself in the presence of two or more bodies. Gravity is quite literally the driving force for the creation of the universe. It's likely responsible for the formation of stars, planets, and even galaxies. On Earth, we experience the Earth's gravity. In fact, it's what keeps our feet firmly planted on the Earth's surface. Freefall is just a synonymous phrase for gravitational acceleration. It's the motion of an object when it's under the force of gravity. And we specifically use freefall when talking about an object that's under the force of Earth's gravity. Since everything on Earth succumbs to Earth's gravity, then without air resistance, everything should fall at the same rate. See it for yourself. Find a piece of paper and a ball, and we're going to perform an experiment and see if they fall at the same rate. So we're going to drop them from the same height at the same time, and let's see what happens. Clearly, the ball is what fell first, right? And that's because the air resistance that was acting on the paper prevented it from falling. So if we actually remove that air resistance by crumpling the paper up into a small ball and do the experiment again, they fall at the same rate. Another example would be astronauts in space. A common misconception is that there is no gravity in space, but these astronauts are literally orbiting the Earth. So if they weren't experiencing Earth's gravity, they would not be orbiting Earth. It's just that the astronauts are in a constant state of free fall, and that's what makes them feel weightless. An easy way for you to pretend you're an astronaut is to jump really high on a trampoline. When the Earth's gravity starts to make you come back down, you will briefly feel weightless. The term weightless brings us a good segue into defining the differences between mass and weight. Mass is the amount of matter in your body. Weight is the measure of how the force of gravity acts on that mass. This is why people say you would weigh less on the moon than on the Earth. And that's because the moon's gravity is actually weaker than the Earth's gravity. But the mass of your body on both planets is still the same. So it's actually the difference in the force of gravity that changes your weight. A good way to imagine this on Earth would be to just use an elevator. When the elevator is moving up or down, it's actually briefly changing how Earth's gravity is applied to the mass of your body. So when you're moving in an elevator, your weight is actually changing, but the mass has not changed. In order to change your mass, you would have to lose an arm or something to that effect. All right, so how are you feeling? Because you're doing great, and let's quickly recap. We describe the motion of a body by defining the speed, velocity, and acceleration, and how the force and momentum characterizes the changes of this motion. We learned how gravity is a force, and that free fall is just the motion of an object under the force of gravity. Next time, we will discuss Newton's laws of motion and how it predicts this motion based on the basic principles that were outlined in this video. Don't forget to subscribe to this channel if you like this content, and check out our other playlists for astronomy-related content told by the experts themselves. Let us know in the comments below what sort of questions or comments you have. See you next time!